You must have seen ice melting into water and then water evaporating into water vapor. Matter can change its state. And in this video, we will look at what happens inside matter when it changes its state, what happens to the particles of matter when there is a change in state. So to begin with, we have a beaker with some ice in it, and there is a thermometer attached to it. And we will start heating this block of ice. Now, as it heats up, the temperature in the thermometer rises and it reaches a certain point. This is a point when all the ice that we see, it starts changing into water. Now at the particle level, if we zoom in, so let's say we have ice to begin with, and we have all of these ice particles. There will be many ice particles because it's a solid, right? So it will be tightly packed. There are all of these particles of ice. Initially they are vibrating about their position, but when you supply heat, it increases its kinetic energy. So it means they start vibrating faster about their position. And as you keep on supplying heat energy, there comes a stage when these particles are able to break these forces of attraction between them, and as a result move around more freely. That is when solid starts changing into liquid. When ice starts changing into water, what is observed is that the temperature remains at 0 degrees Celsius. So ice starts changing into water, the temperature remains at 0 even if you're supplying heat. And then until and unless all of the ice has been changed to water, the temperature doesn't increase. It stays at 0 degrees Celsius. This temperature right here, this is called the melting point. Melting point is the minimum temperature at which a solid starts changing into liquid. If the melting point is higher, let's say if for some substance melting point is 50 degrees Celsius, then it means that it has a stronger force of attraction between its particles. So it needs more energy to break them, right? But for ice, it's 0 degrees Celsius. Now when ice starts changing into water, even if you supply heat, the temperature remains at 0 degrees Celsius until all of the ice has been melted. That is because all the extra energy that is being transferred, all the extra heat energy, is used up by these particles to break all of these forces of attraction. When all of these forces of attraction have been broken down, when the particles have overcome these forces of attraction, when all of them start moving about freely, then again the temperature starts rising. So we have reached a liquid state. Now when you keep on heating it, the temperature rises further, and there comes a point when the water starts boiling. And boiling is a bulk phenomenon, which means it happens throughout the body of the liquid. The water starts boiling. Water particularly boils at 100 degrees Celsius. This is the boiling point. And boiling point is the minimum temperature at which a liquid changes into vapor, into gas. Again, when you keep on supplying heat to liquid, the particles that are already moving around freely, they start moving with a higher kinetic energy. They break the force of attraction that are present between the particles in a liquid, and they move around with a higher kinetic energy. So we see as there is a change in the arrangement of particles, that gets reflected in the state of a substance. When particles are closely packed, then it's a solid state. When the particles gain enough energy to overcome the forces of attraction, that is when they break these forces between them and become a liquid. And on further providing heat, the particles further gain kinetic energy and turn into a gas. So on increasing temperature, you can go from solid to liquid to gas for any substance. Now let's have a gas in this piston. So we have seen how temperature affects change in state. Now let's see how pressure can affect change in state. So we have a gas in the system. This is a piston, and what we will do is we will decrease the volume of this. So we will push the piston down. We will push it down, and as we push it down, we see that the particles, they now come closer to each other, right? Because there is less volume in the container, and as they come closer and closer to each other, gas turns into a liquid. We need to also ensure that there is low temperature in this system. There is low temperature as well. So here, when we have increased the pressure, they are so close to each other that they start attracting each other. There is an intermolecular force. They start attracting each other. all the particles attract each other and then they move around freely. That is how gases can be liquefied. So even increasing pressure has an effect on the change in state of a substance. One example of this is solid carbon dioxide. Solid carbon dioxide is stored under high pressure. And when solid CO2 is brought into contact with atmospheric pressure, that is 1 atmosphere, then it directly changes into gas. So increasing pressure can liquefy gases, can also solidify gases, and when you decrease pressure, the opposite happens, just like in the case of solid carbon dioxide.